Hi, so now we look at the law of cosines. Remember, we looked at the law of sines, and the law of sines helped us when we had angle side angle or angle angle side. So that's how the law of sines can be used to solve a triangle. However, how about the law of cosines? Let's take a look at that. So the law of cosines is used when we have side angle side or side side side. And here is what the law of cosines states. I'll write it out, and as with the law of sines, we're not going to prove this. Proofs are in the book. Your teacher may prove it. So we're just going to look at how we use the law of cosines. So that's what the law of cosines, that's one version of the law of cosines. There's two more that are basically parallel to that. But notice that if the measure of angle A is 90 degrees, in other words, we have a right triangle, then the cos of A is 0, and this whole term is gone. And in the case where A is 90, and then A is the hypotenuse, we simply have the Pythagorean theorem. So this is sort of the extension of the Pythagorean theorem to the situation where A is not a right triangle. So as I said, there's two more versions of this using the other sides, and I'll just simply write them down for you to see. Okay, so notice that all of these are basically saying the same thing. Here is a side. These are the squares of the other sides, the product, 2 times the product of those two sides, and the cosine of the angle opposite this. And that relationship holds in each of these next two statements. So we just have to figure out which is the one we use, which is essentially which is the one where we have an angle, or when we have the 3 sides, we can use any of them. Okay, so as always, let's look at an example to hopefully help you understand this. So here's our standard generic triangle labeled, and let's look at a case where we have side angle side. Okay, so here is everything labeled. Here is the information that I'm given, and here it is represented on my triangle. So think about this. Which of the 3 versions of the law of cosines do I need to use here? Right? Since I have this angle, I need to use the one that starts with a B. So let me write that down for you. Okay, so that's the version that we need to use, and all I'm going to do here is just fill in all the information that we have. Check it out. So there it is, all written out, and if I follow this out carefully, I'm going to get that B squared is equal to, it's about 145.298, and so what that means is that B, side B, is equal to 12.05. Okay, so that's side B, 12.05. Now, what do I need to find? Let's suppose we're going to find angle C. Okay, here it turns out that it's best to just go back and use the law of sines. So let me write down what that would look like. Alright, so this is the version of the law of sines that'll help. The sine of angle C over side C is equal to the sine of 50 degrees, B, over, now I know what side B is. And it's very, very important now to make sure that your calculator is in the right mode so that you don't make a mistake with radians and degrees. But if we solve this, we simply get that, where are we? That angle C is equal to about 22.4 degrees. So we know now what angle C is, we know what angle B is, and so it's pretty simple, right, to figure out what angle A is, and it's going to be about 107.6 degrees. And there we go, we have solved the triangle given side angle side. So one more example, and that's the example in which we'll look at side, side, side. Okay, so here's our standard triangle, and let's assume that in this case we're told that A is 10 and B is 9, and C is 4. So there's 4, what's B? B is 9, and A is 10. So what we need to do is find the 3 missing angles. So here it really doesn't matter which form of the law of cosines that we use. So I'll just write down one of them and we'll use it. So here's one of the versions of the law of cosines. And what we're going to do now is simply plug in everything that we have. So that'll make it look like this. So what we're going to be solving for here is the cosine of A. And if we solve for the cosine of A, we get minus 1 over 24, which means A is going to be in the second quadrant, which means it's going to be an obtuse angle. And if we solve this correctly, again, making sure that we are using the correct units, we're going to get angle A is equal to 92.39. I'll just write 92 here. Okay. So what we do now is use the law of sines, and we can do that to find the measure of angle C, which we know has to be acute. Can't have two obtuse angles. So let's write down what the law of sines is going to look like in this case. Okay, so check it out. Make sure you believe that that's correct. And if I go ahead and solve that for angle C, I'm going to get angle C is equal to about 23.56. So now I have two angles, and I can get the third angle by just figuring out that they all have to add up to 180. And so the measure of angle B, I think, comes out to be about 64.05. So please do notice that I had one application of the law of cosines, and then I could use the law of sines. Law of sines is easier if you can use it. Alrighty, so that takes us through the law of cosines, and next time we'll look at what is known as the ambiguous case, when we're given side-side angle, and we'll talk then about why it's ambiguous. See you then.